Dive into the deep end of application security with Kyle Hankins. He flew in to sit down and talk about the red team and blue team aspects of application security, as well as how AI fits into it all. There's a lot of speculation around what AI might be good at or bad at application security and network security, so this was a good chance to sit down and go through it and discuss that level of nuance. So with that, please enjoy this conversation with Kyle Hankins. Hello and welcome to the Arsenic Show. Today we have Kyle Hankins. How are you, sir?
Thank you. Doing well. Pleasure
Great.
to be here.
Yes. You came down from Denver.
I did.
All right.
Nice and early flight.
Yeah. How's the weather going up there?
Awful lot cooler and drier than it is here.
Well, yeah, it started raining today. I think it's gonna be raining for the next couple of days, if memory serves. Which it's kind of inconvenient timing. Got a lot of stuff I got to do outdoors, but Texas needs the rain. So there we go. So you came down to talk about web application security. I hear you know a thing or two, and so it's going to be good to hear your take on it. But you've been in web app sec for something crazy like 2 decades as well, right? So
it's kind of a mix. I actually started my career as a software dev, so I've been on both sides of the house, and then migrated into security, and then management of security.
That still all counts.
Fair enough.
So when you were a dev, I'm assuming a web dev?
No, actually. So, my field really is more than just web app security. It's just AppSec in general. But I'm a grouchy old C coder.
Interesting.
I went to college. I got myself a Russian degree, Russian language and literature. And as any good Russian major does, I went directly into software. So I did some work for
disinformation campaigns, obviously.
Right. Yeah. So I did some work for at the time it was Bell South. We were acquired by AT&T while I was there. We called it the data analysis and technical assurance team. It was kind of big data problems before there were big data solutions. So we would do, work on customer records databases, terabytes of data, mostly having to write our own tooling at the time.
Interesting. So what got you from C into web application stuff?
More specifically, I ended up in security because I had a bit of a history in it. I had sysadmined my way through college, mostly because I worked with a guy named Alex Soderov, who...
yeah, I know him well.
Yeah, so I went to college with him, lived in the same dorm as him. I had gotten frustrated and was wiping Windows and putting a stage 1 Gen 2 install on my laptop, and he offered me a job. So did some sysadmin work through college, and that got me into software. But Alex,
what was the job? What were you doing?
So I was did systems administration work for the University of Alabama Arts and Sciences Lab. So,
is that where he was working?
It was.
Oh, that's funny. It's funny how many security people come out of the kind of the social studies, like linguists. Like one of the guys who taught me how to do security, Bronkbuster, he was a history major,
Well, it's kind of funny because I think...
art history.
Art history. That's the creative aspect of the job. It's actually kind of funny because, at the time, you didn't really go to school for security. At the time, you didn't even have to go to school for software.
Well, there wasn't security schooling back then.
No, and at least at the time, it was generally like people were really antsy about even the idea of teaching, security concepts because they were still trying to figure out ideas about like liability and risk in software education.
Mm-hmm.
I didn't really have any trouble rolling into software, but because I had a background with Alex, I had some security on my shoe. Which meant I ended up in security sort of related work over time. Eventually, I was doing like triaging on scans for some DoD contracts, and got picked up by a security consultancy.
Mm-hmm. And in that, so to me, typically C programmers stay more on the buffer overflow side, the memory corruption issues, that kind of stuff. and rarely get into web applications. Or if they do, it's more the memory corruptions of web applications.
Yeah. I ended up doing attacks on web, on native code.
Native code. Okay, that makes sense. Right.
So, we do at Coalfire, which is where I work now. We do architectural security, native attacks, web attacks, cloud attacks. If there's something you need done with your security practice, we'll go in and do it. My particular team focuses not just on web, but on all application security. So if it has to do with writing code, deploying code, scanning code, attacking code, we have offerings to support it. In this particular case, the team has grown a great deal. Coalfire at this point, has around 60 people working on my team. And
so what would you say the breakdown is? Are you mostly, binaries that people are trying to exploit kind of thing? Or are you mostly web, or where's sort of you?
So in terms of, my personal preferences, I love to slash up a binary. That's a lot of fun. Realistically speaking, the majority of the work that comes in terms of just raw application assessments is going to be, web apps. And mobile to a significant degree.
Oh yeah, that is growing a lot. So what is sort of the major differences between those three? Like, how would you kind of bucketize the work? Yeah.
Because we're working on that sort of white hat side of things, we rarely get to slice up the binaries. Native code is often, a more white hat or a white box exercise. You have the opportunity to run scanners on code, examine the code, find problems that way, as well as test live. That's sort of, the difference between, just going in, grabbing something and doing a bug bounty on it versus...
What are they calling that now? Purple testing or something?
Yeah, something like that.
Yeah, okay.
As far as web goes, that's often just a URL that's provided to us, and is probably the more frequent of the three.
I've also heard gray box.
Gray box testing would be...
I've also heard that one.
And then mobile, every mobile engagement is special. There are so many different platforms and so many different ways people release and so many different ways people manage their code that getting a testing environment is always a bit of an adventure when standing up mobile.
And also includes things like mobile devices other than phones as well.
Absolutely.
Tablets and so on.
There are so many different form factors that can roll in, not to mention IoT, which can, sort of cross several of these boundaries. In the end, each one of these things kind of has to be approached on its own merits, and the engagements are typically customized to the needs of those particular clients.
I'm curious, what is mobile app testing like these days? I mean, I've done some of it back, it's probably 8 years ago now or so. And it was a lot of just, you would actually have to have kind of a hacked environment that was just kind of monitoring it, more or less just is kind of like running like Burp Suite and just trying to mess with the protocols or the API calls or whatever it's using. And maybe you could dump out the binary and find out that they were using a shared credential or something, but that there wasn't much more to it.
There are a lot of neat tool suites and sets out there, and that's great. But realistically speaking, it still has a lot of vibes along those lines. What's nice is that there is SAST and DAST tooling that's available to kind of get you that first few steps in. But you are still often hooking up Burp Suite and otherwise testing it a lot like you would a web app. In fact, most apps can be tested to some degree like their web apps, with the additional then layering on of sort of those phone-based controls and environmental concerns.
And how do you do scoping in that context? Because it seems like you kind of have to know all the API calls it's going to make ahead of time to know how to scope it.
Scoping can be challenging. The sort of short version there is I love nothing better than to see a demo of the app just to kick it off, in that you can often infer a lot of behavior if you can just see the app working. But you do have to pay attention to how many different platforms you're going to have and talk to the client about whether they're going to want to test them all or test one. You want to understand when it's a shared code base, what some of the dependencies associated are. When you can get access to source code, that goes a long way, again, towards scoping. We do have some clients that'll give us, prior access to those sorts of things so that we can get a good feel for it.
Do you prefer hardware versions of it or stuff like SAST labs, or like what do you use?
A proper kit full of hardware devices is always the nicest option. Sometimes you have to roll to those software pieces. In particular, there are certain tests that can only be performed on jailbroken devices. Some pieces of software don't work so well on jailbroken devices by design, which is good. Once again, those mobile tests end up being customized a little bit to the circumstances of the individual clients. What kinds of controls they have on it, whether they'll provide us unlocked versions of the app or not. And we've gotten pretty good at working our way around those pieces when we need to. So.
Yeah, I just feel like if you have a mobile app, you're almost certainly going to have a manual test. It's not like web apps where you can just flip on some arbitrary scanner like Arachne or something, and it kind of goes through, and it maybe doesn't do a great job, but it
gets you halfway there.
It gets you halfway there. There's really no halfway with mobile.
Not aside from some basics. You've got some things like check marks that'll do the source code scanning, and that's lovely.
Sure.
But those come with all.
If you have it.
Yeah, and I'm sure we could talk about this more later, but it's difficult even when you do those. Many companies don't do a very good job of reading and triaging them. So you can run scanners all day long, but unless you're going to have somebody go through and sort of weed out the false positives and vet the contents and then make use of it, then it's still not going to provide that much value.
Yeah, without saying the vendor's name, I did a assessment of a potential competitor years ago, and it was, I don't know, something like 50 pages or something long. It was quite a long document, and each page had probably 10 different issues on it or whatever. And I went through this thing. It took me almost a full day to go through this thing, and there wasn't a single real vulnerability anywhere in that report. Not one. It was like, if you were a local user and you wrote to this file and you were root, then you could do this. I'm like, what? If I'm root, I could do anything. What are you talking about? And how do I get there?
And we have an awful lot of vendors that still use semantic analyzers. Merely putting the word password in a comment is enough to get somebody to have to review this thing.
Right. Or to do.
Right. And it's we do a lot of security program development where we'll go in and try and stand up things like SAST and DAST and get those incorporated into people's SDLCs. And one of the big problems that we have is even people who are buying the tool don't really know how to use the tool well or properly, how to get it up and running and actionable in their environment.
Do you have a preference on SAST and DAST?
I do.
Yeah.
I have conflicting preferences. So I still have a fondness for Fortify, for example, that has the ups and downs associated with it. It can be a real pain in the butt to get up and running. And it's amazing how many people can't compile their own source code when you get down to it, which is necessary for that kind of thing. Sure. I'm fairly fond of check marks as an alternative for something that's really easy to stand up, but you have to be ready to deal with the false positives that deals with. Those are my personal opinions.
Gotcha.
Take them as you will.
And DAST, you like from what perspective exactly?
So I have mixed feelings about DAST in general. Something automated, like running a burp scan in some automated fashion is always a pretty good idea. We've had good value from things like AppScan, but the results on DAST have often felt a little bit more hit or miss, and it's often a little harder to get up and running in effective ways. It's also fairly delicate much of the time.
Yeah, I've taken down websites for sure.
Yep.
Some pretty very everyone in the world would notice if I took this thing down, and I almost did multiple times.
Every time someone goes to run a DAST scanner, it's all right, think before you click that button because the effects can be very real.
I would love to hear a horror story if you've got one, because I've got a couple. I will share with you if you'd like.
So I don't necessarily. I'll hold off on the horror stories for DAST. I definitely have cases. A personal favorite, deliberately inspired horror story, in which I was working for someone who scans were being run regularly. That was great. getting people to do anything with those scans was much more challenging. So the teams were running their sprints, they were booting things up, they weren't actually taking any of these and replacing feature efforts with fix efforts. And so with approval, went in and just exploited one of those stored cross-site scriptings. Popped up a message, you're being hacked right now on the top of everybody's dev page, on the main page when they booted anything. And then just sat down and looked out the office. And
everyone's popping their heads up.
It's like whack-a-mole. The heads start popping up, the noise starts building, and for the next 2 sprints, all fixes were security fixes. Everything else was paused.
Interesting.
So it's always one of the great things about being in this industry is that you get to see the impacts of what you do in fairly meaningful ways. So.
I have some real actual horror stories, but this one didn't end up being a horror story, but it was a hair's breadth away. I've got a number of these that were very, very close to being tragedy. But this one, I was basically just doing Dirbuster effectively. I'm not sure if it was exactly that tool, but something like that, directory enumeration. And it's a very simple attack. All it's basically saying is, does this file exist? Yes, no. Does this file exist? Yes, no. And it does a lot. Well, I ran it on this one particular machine, and it ran out of memory. It just ran out. I mean, it's a benign attack, really, but it was never designed to handle that many requests. It gets 1 request a day is what it's for. It gets exactly 1 request per day, and I was hit with millions.
Yep. I have a very similar story with it was an email password reset routine. And they determined there were no brute force protections on it, and that you could get enough info out to mine out username it was username enumeration that they were executing. The problem was that it was also sending triggering mails on their system. So we triggered up the attack, and it filled their mail space basically immediately. Hard stop to all email.
Yeah, and see, this is why for me DAST. There is no safe way to do DAST. I don't care what anyone says. Agree. No safe way to do it. Now you can get safer. It might even get to the point where nothing happens ever, but it's still not safe. It's just that you lucked out. Like a good example I like to use when I'm trying to explain this to people is, imagine I have a dev server, and on that dev server, there's no users. And so we're thinking, this is safe. What could you possibly do? It's on a different network. It's totally safe. But it's exactly the problem you just said. Yes, but someone copied the database over so I could do testing. So the emails are still valid. And so if I start doing these types of attacks, it start to actually email people for real, and you're causing all these back-end problems and customer support issues, and you're just thinking this is a tiny little dev box.
Yeah, and one of the perks of the kind of manual testing that Coalfire often does is that we have folks that are pretty competent and confident in detecting when something has gone awry. In the case you mentioned, we see variations on that very regularly, where in theory we're supposed to be working with fake data, nothing sensitive in there, and our testers will get in there and they'll be like, I'm seeing things that look awfully real. Let's put a pause on this and talk to the client and find out if this is all kosher.
Yeah. Yeah, I don't know exactly what to do about that. See, I prefer DAST testing almost always, not because I think it's more comprehensive. I don't think that. But I think it's more realistic about the kinds of issues that bad guys are going to find in practice, with the exception of mobile, because they're going to have access to the binary.
Right.
But yeah, it's just not safe. It really is not safe.
And you mentioned mobile. I feel like that's mobile suffers from that same kind of structure problem space as IoT, where a lot of security, as it's grown up in our industry, comes with certain assumptions about the sanctity of the physical device. And now that we're moving into a world where IoT and mobile devices are everywhere, those kinds of assumptions often don't hold, and people haven't sort of adapted yet to that reality.
Yeah. So you have been in computer security for whatever it's been, call it 20 years now. What have you noticed in terms of not just technology, but let's talk about culture, like how things changed in the industry from your perspective?
So In a lot of respects, I think people are more aware of security than they were some years ago. If you go back to a conversation I was having, I don't know, 10, 12 years ago, I would point out a cross-site scripting vulnerability, or a better example would be like a SQL injection vulnerability. And people would just kind of respond with, well, that would be really hard to get to. You know, if they have access to an interface that can touch that, we're already hosed. And I think people have gotten a better idea about this sort of defense in depth message that we've been preaching for a long while. Mm-hmm. And so we're starting to see those pieces develop. And we're seeing people recognize the need to roll security further and further to the left. You know, this is why we have offerings that we're developing specifically to help people do that. The downside to that is that I don't think we're necessarily taking care of our cyber hygiene yet. Mm-hmm. So you have an awful lot of people who realize that they need to buy, you know, SAST or DAST scanners, and they have nobody to review the results. They don't have any good way of passing that to their developers. You know, they don't have people on staff yet that can necessarily read and interpret and prioritize those pieces. So I think
what do you think about moving to the left? Is that so? That sounds amazing for greenfield applications, but mm-hmm. there's a lot of applications that aren't.
There's a lot of legacy code. In general, I think moving to the left is still important, but all of this comes with a need to have a clear and cognizant view of what the risk and impact and, you know, level of effort to fix are for any given case. I definitely don't feel like those legacy applications should bury their head in the sand. They should certainly be, you know, scanning. They should be using those scans. They should be interacting with them and working them into their cycles. At the same time, you know, you won't be able to boil the ocean. So it's important to have, you know, a clear view of what can happen with any given finding and sort of work through that.
Mm-hmm. Gotcha. And from a technology perspective, what do you think the major changes are other than we have mobile now?
We have mobile. So there have been a few, and we're going to, you know, dive into more, I think, in the next few years. Like if you go back to like the mid-late 90s, then yeah, it's smashing the stack for fun and profit. But I think at this stage, you know, there are fewer and fewer of us C-code dinosaurs running around. Mm-hmm. We're seeing more and more, you know, security controls on, you know, native applications. But at the same time, we're rapidly expanding our attack surface in other directions. You know, if you go back,
sure are.
if you go back like 10 years, you saw IoT blossoming, and everyone was putting smart everythings everywhere with no security controls, no ability to shut down individual components of their IoT networks. If you go back go back 5 years from now, then you're looking at like microservices blossoming. Everybody's got a Docker, they're tossing that puppy out on the network, and network segmentation just goes out the window. I think right now, obviously the big topic is artificial intelligence. You know, you basically can't look at a product that's not trying to squeeze AI into its interface somewhere. Mm-hmm. And there's not much thought going into, you know, how to build that securely, what the risks are associated with that, or even for that matter, what the rewards are associated with it. I think in a lot of cases, people are doing it because it's interesting. They're not really considering whether or not it matches their particular application's use case. So we're seeing, you know, a rapid expansion of an attack surface without, you know, commensurate gain.
Okay. So I think that dovetails us nicely into AI. So security is all kinds of things. It's not one thing. It's many, many, many sub things. Like you have threat modeling, for instance. You have source code analysis. You have just GRC stuff, right? There's all these areas of security that are not necessarily what people think of as hacking per se. But I think that you could probably bucket them all into kind of two major categories, red teaming and blue teaming, right? Red teaming being finding bad things, blue teaming being stopping the bad things. Mm-hmm. And stopping the bad things might include GRC, it might include threat modeling, et cetera, right? That's all inclusive of stopping bad things. So we don't have to get as narrow as individual subtasks for this conversation, I don't think, but maybe we do, I don't know. So I think it's probably first useful to talk about red teaming, mm-hmm. because I think that's what most people are concerned with. And if we're going to talk about one thing, it would be, how can AI help bad guys do bad things faster or better?
Absolutely. And right now the answer is, oh gosh. I think it's worth taking like a moment. And I know longtime followers of your show will have heard some of this before, but it's worth sort of commenting on the fact that these large language models, for example, and we could talk a lot about all kinds of generative AI, but the LLMs are sort of taking center stage right now with things like ChatGPT. I think the most important thing that's important to understand about these is that they are not designed to provide truth. An LLM is somewhere between Clippy and autocomplete on a grand scale. It's designed to give you plausibility instead of truth. Whatever comes out should be very, very reasonable sounding. And the fortunate thing is that truth is usually more plausible than fiction. That's just not a guarantee. So when you get to attackers, that's a really good example of a case where is perhaps more than defense provides a benefit. If I'm trying to run blue team, if I'm trying to defend my network, then I have to be right more or less 100% of the time. Any given mistake that I make is some level of Armageddon. For an attacker, they need to be right once out of however much they're tossing out there. So the really good example here is phishing. And it's providing a lot of potential benefit there in several different ways. For one thing, in your case, what would be the number one way that you would tell your grandma to pick up that something might be phishing if she's reading email?
Well, grandma, I probably wouldn't have her on email in the first place, but yeah, I mean, I think there's many tricks, but I think the one you're alluding to is spelling and grammar.
Absolutely.
Yes.
So at this point, AI is capable of taking a lot of that primary tell for phishing and wiping the slate clean on that entirely. And even fairly like well-constrained LLMs, ones that are doing their best not to let you write a phishing email, can help correct grammar on something. This is broadly applicable to these things. And then that can only become worse once you start incorporating some of the more exciting aspects of these sorts of generative things. Typically, for example, let's say you wanted to build a misinformation campaign. Typically, this would be like a state actor level engagement. You need multiple websites. You need 100 or 200 sock puppets putting reviews about this sort of fake company you're setting up.
Spear phishing. You're talking
Absolutely.
about. Yeah.
Now these sorts of like zombie accounts can be set up, run, maintained, all with a fraction of the effort that it used to take, and can be used to create like very plausible misinformation or provide support for spear phishing campaigns.
Mm-hmm. Okay, so what about the actual attacks themselves, or attacking software or hacking into websites or whatever?
So what's great about a lot of these pieces or a lot of this technology, great, terrible, is that it can be adapted in a lot of ways. They're
dual use.
Exactly. So while the easy one and the one that people will be most familiar with would be a ChatGPT-esque fake email generation, writing prompts, the like. There are tools such as WormGPT that are explicitly trained and supported to try and do these sort of targeted attacks. You can use well-trained models to help you write code. Similarly, you can use well-trained models to help you write malicious code, or at least adapt it.
Yeah. What for those who haven't heard about WormGPT, what does it do?
So it's effectively a well-trained LLM that focuses on malicious behaviors. So in the same sense that I can log on to ChatGPT and ask it to help me write a little mobile application, an attacker could log on to WormGPT and ask it to help write a phishing email or ask it to help produce malicious code.
Mm-hmm. So one of the things I've found that I think is probably one of the more interesting use cases for the thing that everyone's worried about, they're trying to come up with like, what's the worst thing? There's a lot of worse things. But one of the worst things is faster time to the X. So right now we have companies like bit discovery once upon a time, where I basically have this massive amount of data. It's all in one big database, and I can just query it. So that's great. That speeds up time to the X a lot, like a lot. Used to take maybe days or something to port scan a company completely or whatever. Now I can just query it in 10 seconds. I can have all the data out of the system in an organized format, or maybe even organized to the very specific thing I want to look for, not even just like a raw dump. Like I only want to see the things that are probably vulnerable. That's all great. But I think that there's another set of things, like if you take in pieces of data from websites and you're like, okay, this website looks more interesting because of XYZ, or this one looks like it probably has a member system behind it or something. It's like, yeah, I could attack anything here, but preferentially these are the ones I'm really after. And so I might hold back and not do the attack purely because it won't give me the puzzle pieces that I'm actually after. Or the other way around, like these are the defendable ones. These are the ones that everyone's paying attention. I only want to attack the ones that are not those things specifically, so that I'm off the radar, because no one's going to be monitoring this tiny little thing off the side. You know what I mean? And so feeding that information into an LLM with other attributes about the software stack it's running and the exploit that just came in. So the exploit comes in, and it might be useful or it might be nothing, right? It might be just garbage. But you look at a mailing list, the mailing list says, hey, here's a new exploit, and here's what it looks like, and you just take it, and it's proof of concept. There's some things missing about it, or maybe it's pointing to the attacker's website instead of your website. So kind of rejigger it, turn it into your thing, and now fire it off. And you can fire it off again using something like bit discovery to exactly the targets you're after. And if you preload the assets you're after, as opposed to querying them from something slow, bunny ears here, like 10-second database, where now it's fractions of a second type database. Now, all of a sudden, I can find an exploit, decompile it, recompile it into the thing I'm after with my payload in it, fire it off to exactly the targets I want. And I think you can do all of it with the exception of the LLM part in 0.02 seconds.
Right. And I think it's important to note too, like as security researchers, this is useful. For an actual factual attacker, someone who's looking to use the minimum amount of effort to get the maximum ROI, then the upshots are immense. Because again, what this thing is doing is providing plausible. It doesn't have to work 100% of the time. It doesn't even have to make sense for most of that time. All it has to do is provide something that is reasonably targeted to a wide array of things. It can handle all of the customization on its own. So what I think we're looking at is a significant reduction in barrier to entry for attacks, such that actors that may have been limited in scale before won't be going forward.
So I gave an example of reducing time to the X. Why do you think people are so uptight? Why do you think they focus on that particular metric? I mean, I think there's an interesting aspect about it in terms of time to patch. And so if you can beat the time to patch, okay, but that's not what they're talking about. That's not what people are worried about. They're worried about like how fast you get on my computer. Why does that matter to people?
Yeah. In a sense, I think it's I would just associate it with like this sense of an arms race, that level of urgency. I think to your point, I find the value, the important pieces, to be that gap between when an exploit is available, whether it's public or not, and when a patch is available. So there's something to be said for the fact that when you increase the ease of use for attackers, that you end up with more undisclosed exploits causing trouble. But we're not even doing a good job of keeping up with the ones that are disclosed right now. So I think in the end, the big takeaway that I feel like is important on the attackers' sort of side of the house with AI is just that it's getting easier, and that there will be more tools. We're really just scratching the surface at this point as more of these trained models come out, as models that are, privately held become available. I think we're going to see, an extra tool or 10 in the toolkit and have to respond accordingly.
Mm-hmm. I think if I was to guess, the major reason why people are so concerned about this time thing is they think that means ease. If it's so easy to break in, because you could just do it in under a second, then
well, that's always kind of been the funny thing with our discipline, is that the time to break in and ease are not necessarily very well related at all.
No.
It's like looking at a puzzle and seeing the solution. You might sit there for 2 seconds, or you might sit there for 2 days, and it's a question of how your brain like puts the pieces together.
Mm-hmm. But also some attacks, they just take a while. They honestly, like blind SQL injection or something, that might take you days to get the data out of the database.
True.
So it's not like the attack is hard. It takes a long time to run. I mean, or a lot of enumeration attacks, for instance, like just you click one button and then you walk away, and like 3 days later it's half done. You're like, ugh,
It's the XKCD compiling joke.
Yeah.
You're hacking and drinking coffee or whatever, watching anime.
Exactly. I find it very strange that that's still something I have to explain to people, because they have to experience that in other areas of their life. Like, well, how easy is it to do dishes? Well, sometimes it's super easy and sometimes it's hard. Like, it just depends on like how many you have and like what's going on and
what's on the plate.
Like, and did you burn something or not? Like there's variables. It matters. Like, life is complicated and messy. So I think that one thing I haven't heard people talk about is there might be on the red team, specifically the consulting part of red team, not an actual bad guy. There might be a way to use LLMs, the reasoning engine part of the LLMs specifically, which is actually less the LLM part and more the neural network. But this would be, I think there's a way you can use it to be more accurate about the time to fix. You can make more clear explanations about what needs to be done by virtue of the fact that you can feed in a lot more context. And instead of it just being SQL injection always takes, a week to fix or whatever, you know what I mean? Or this much cost to fix or whatever. It's like, well, that one's hard. I can tell it's hard. It's fundamental to the way that the app works. Mm-hmm. Like fixing cross-site scripting on eBay was not a day's worth of work. That is like, you change your entire business model to do it, you know? Or, in the browser, fixing cross-site request forgery. That's not a thing you're doing. You know what I mean? Yes, it's easy to do, but then you just broke the entire internet, right? So I think there might be something interesting there.
Absolutely. And I think there's this kind of drifts into like the merge between red team and blue team, which I guess, is the software creation standpoint. And you're really touching on the thing that I think is probably most valuable for all of us in this particular toolkit. AI may be clippy or, autocomplete, but it serves as an extremely valuable tool when used as a co-pilot. So there are an awful lot of things like, triage, where we could use these sorts of LLM toolings and trained models to help us do these sorts of estimations, or to do the initial write-ups, because we all love our reporting. Covering in some detail.
I've already seen that happening. Like there's companies who are already doing that piece. But I have to. So the thing is, what I think they're doing is they're just feeding in the exploit and the URL and maybe an explanation of what cross-site scripting is, and that's it.
And you could do that with a switch statement.
I mean, yeah, that's like, yeah, correct. I mean, why bother using an LLM for that? But what I'm talking about is you can add on a lot of context. Like exactly. You can give a ton of information about this app.
Roll through each of the source files that are available to you. Highlight the portions of the source code that are going to have to be adjusted in order to make these changes. Follow through that code.
But even more than that, like you could give it traffic. Like how much traffic does this thing get? You could give it, what links to it, so whether this is a thing that's likely to get hit a lot, or what its logs, so does this function even really get hit at all? And so therefore, what's the threat ratio? And you could give a lot more context.
And given all of this data, you can get an awful lot of context. It's just useful. Forget security. It's just useful to know which portions of your website get the most stress, which ones get touched most. Which ways data routes. So.
remember I had a conversation, this is many years back, but a guy at the DoD, he's like, I want to know every single app in our environment, and I want to hit them at least once a minute. And I want to know how long it takes for them to respond. I'm like, that's a lot of traffic. And he's like, yeah, I know it is. But the nice part about it was I'd be able to tell if one's misbehaving slightly.
Mm-hmm.
So if I have a big enough, dashboard of things going on, you can get rid of all the greens. I don't care about the ones that are doing well, but all the ones that are starting to pop up that like, oh, this part of the network's suddenly going slow for some reason. I want to look at it right away. Like what's going on there?
What's kind of nice is that the way that technology is developing right now, we have the opportunity to do things that would have been completely infeasible, 5 or 10 years ago, just from a scale perspective.
Mm-hmm.
The amount of bandwidth we have, the amount of hard drive space we have, the amount of RAM we have, it would have been a limiting factor on lots of these kinds of efforts in the past. And now, with proper architecture and design and planning, versions of those can be done.
When I was at BitDiscovery, one of the very tail things I did right when I was leaving was I basically took a whole bunch of websites and I fed it into ChatGPT. And some of them I knew were correlated for a fact because I had handpicked them. And others I knew were not correlated because they were totally different companies.
Mm-hmm.
And it was a small list, I think like 10 or something. And I asked it which one of these are correlated. And it did a okay job, I'd say, slightly better than average. But then I gave it context. I said, okay, what if I told you this is the email address associated with these things and whatever? I give it a couple different parameters. And it did as good a job as I would have done. It was amazing.
It's funny you mention, because yes, I've kind of looked at ChatGPT from two different sides here. One would be looking at it from that sort of, from a SAST-ish perspective and how it could help on defense. And then the other from the software perspective, which is its own ball of wax. The internet is rife with people talking about ChatGPT replacing software engineers. I have some opinions about that too.
Okay, go ahead.
Okay. So as far as writing software goes, I decided to experiment a little bit. I loaded up ChatGPT and I tried to write a very small mobile app, like a habit tracking app. Did I have a glass of beer today kind of deal. For four different, four-ish different screens, local storage only, and I wrote it in Flutter, which was a language I knew exceptionally well. I'd written applications in recently. So the goal was to see how well it could do that. And in the first few minutes, it was very encouraging. It can do a lot of the really trivial, set up a project from scratch and get the basic stubs in and get some basic functions in. All that was pretty good. And each time I was done, I would ask it to regenerate the files, and then I would go to compile them.
Oh, there, that's the problem right there, regeneration.
And it's funny because when things were small, it was doing great. But as you run out of tokens or as the project grows in size, and it doesn't have to grow very much,
no.
It starts losing that context about what you were doing in the first place, what you said. So it'll start mixing and matching things. It'll destroy code as rapidly as it created it. Mm-hmm. And so immediately I started hitting those roadblocks. And
it also will hand you more or less diffs. And you're like, ooh, but it's not in diff format. You're like, oh my God, where does this go?
Gives you a diffish thing. And I'm like, all right, cool. Reincorporate that and regenerate the file.
Yeah. Nope.
And then it gets worse because it starts getting confused. It'll go a little further and it'll start recommending functions that don't exist and have never existed. Not because they don't look really good. They look very plausible. But
they sound good.
But they're not real. And so the more you dive into it, the more you see it's really great when you're doing something very surgical. It is far less capable when it's supposed to be dealing with something at a larger scale. And then the sort of third nail in the coffin on this one is that it starts making mistakes. And the mistakes that it makes are, given its training data, unsurprisingly, the kinds of mistakes that humans make. So when you start doing work with asynchronous calls in Flutter, humans will often struggle their first few times, and the same data that they're writing up on Stack Overflow is the stuff that's driving this code. Never mind the fact that it's also a couple of years out of date.
Not anymore.
Not anymore.
Yeah, that's
depending on your version.
Yeah, so, right.
So many of these will improve. We'll get access to more tokens as scale goes up, or you can pay for more tokens. The business models being what they are, but many of the core problems are inherent to LLM. This lean towards plausibility as opposed to truth is going to bite really hard with code. So if you're using it to support a language that you know well, something you're very capable in, it's an amazing tool to accelerate what you're doing. Used properly. If you're trying to go in and write in a language you don't know, doing things that you're less familiar with, you may find that it falls short in fairly destructive ways fairly quickly.
Yeah, I was mentioning this to somebody at some point. I can't remember if I said it on the podcast or not, but there was a situation where I had it build a registration function just out of curiosity. I was doing almost exactly what you were doing, just trying to see if I could build a simple app. And it worked okay. It was actually, it did exactly the very specific thing I asked it to do within reason, except for it didn't lowercase the email address. And so now you can have email address collisions in the database with some people having uppercase or lowercase or whatever. And that's one of those things you only really know if you've got experience. You know what I mean?
Mm-hmm. And that really gets into, to reel us back into security. That's exactly some of the concerns that I have in this sort of boom of ChatGPT created code going into production. Is you have an awful lot of people that kind of know what they're talking about, or worse, don't, creating code that is then going live. And it was difficult enough over the last couple of decades getting people to pay attention to security if it was their literal career. Sort of back of the napkin crafted code from ChatGPT, it's going to be it's hard enough for a seasoned software developer to recognize somebody else's mistake in somebody else's code. Now we're seeing an awful lot of people that are publishing code that they didn't directly write, and they don't even have the expertise in the language that they're writing in to detect when those sort of failures are slipping in.
So, I mean, you say that, but it feels like there's an upside here too. Because now you could have a GPT that has samples of all the known exploits, like really well explained samples, and say, I would like you to run across each one of these samples against this piece of code and see if this problem exists anywhere in here. So that, if there's ever an email address taken from user input, it should be lowercase as an example, right?
It's actually funny you mentioned, because this is the other side of it. So taking the defense and sort of SAST route, I took a bunch of known vulnerable code where I knew it was explicitly crafted to have a bunch of vulnerabilities in it, and ran that through ChatGPT. And I was genuinely impressed at the things it found. It found things that even fairly seasoned practitioners frequently miss, and in some ways performed better than common SAST tooling does. Specifically when it got to some of those logical vulnerabilities that we say SAST tools struggle with. So for example, it was able to detect that in this code that I was passing it, the lack of an encryption routine on a password field suggested that the database was storing that password unencrypted.
Yeah, that's great.
And those are the kinds of logical flaws that are pretty hard to pick up, for a static tool.
Or with double equals versus triple equals or whatever.
Logical flaws in general, flaws related to pass-throughs, flaws related to try-catch issues, can be difficult to detect when they, or even just saying, oh, this probably should be a restricted API and it's not. The LLM is a little bit better about saying, hey, the name of this suggests that it's pretty important, but I don't see any encryption routine. Now the downside is that just like SAST, even more than SAST tools, you can get false positives. It can report on things that literally aren't in the text at all.
Right.
So once again, it's really aided by having a...
This is where I think metacognition is really the name of the game. And once the different GPT developer types, or really, frankly, anything that is generative, this could apply to video or text. It doesn't really matter. Any place where you have something that's outputted, having another AI, preferably not the same one, but you could even use the same one because it often works. You could just say, hey, take a look at this. Does this look right? Like, and describe what you see here and make sure that this actually makes sense. Do people have 6 fingers? Because I see 6 fingers. You know what I mean? I mean, some people have 6 fingers, but not
most.
And did I specifically ask for 6 fingers? I did not. And therefore, you know, what's the problem with this photo? And, or, you know, in this case, yeah, you say this function existed. Okay, make sure this function existed. Did it exist? No. Well, then why did you say there's a function? Oh, sorry. And then it'll fix its errors.
Right.
Assuming is enough, you know, there's enough tokens there to do what we're talking about.
And then there's some of the hitch. There are a few things that absolutely is an avenue that's being taken in a lot of ways to pretty good effect, up to and including trying to detect when college students are writing, you know, their papers with ChatGPT.
They all are. Come on.
Right.
And if they aren't, they just haven't figured out. They're worried about getting caught, all they need to do is just change the voice. That's it.
It's absolutely true. And that's really the problem is that even with these models that are trained to look at other models, training data matters a lot. You know, getting models that are tuned properly and watching how that data is introduced to avoid, you know, a variety of biases that can creep in.
I was just trying to explain this to somebody literally, maybe it was yesterday or the day before. So I think of it kind of like you're walking down the street and you hear something rustling, you know, in a busy city or something, and you hear something kind of rustling in a bush. One small part of you is going, oh my God, it's a tiger. And you're like freaking out and you think you're going to die because that's, you know, evolutionarily how, you know, our brain works. And then the other half of your brain, the slower part of your brain, the one that doesn't control fight or flight, it's just like totally analytical, will go, we're in downtown.
Yeah.
That is definitely not a tiger. That bush is way too small for a tiger. Also, like there's 100 other people here who would have attacked them first. And you can see that there's nothing underneath that bush. You can see under the bush, like that is clearly a bird. What are you doing? Why are you freaking out?
Jumping from the bush has kept humanity alive for a long time.
It really has. But in modern society, our metacognition, the more logical, slower running, but more logical part will go, yeah, it's a tree with a bird in it, or that was a bush. Like, what are you doing? Like, just relax. So in AI's terms, so you have the fast running thing that just, you know, it's like, I think it's this. Yeah, whatever. And just throws some best guess out there. And it is more or less text complete at that point. It's better than that. And I don't want to diminish it too much.
Right.
It actually is better than that. But then you have the slow running metacognition on top of it. It goes, okay, so you think this thing is true, and like you've come up with this thing. Now I'm going to go double check all of your work. Like where did this come from? Like how did you make this assumption? Do these function calls exist? Is this really an exploit at all? Like, you know, just it can go and do the hard part of that. But since it doesn't have to run billions of times over every single, you know, bit and byte of all of the text, it only has to run on the findings. It can run slower without being terribly annoying. You know, it can just take 2 or 3 seconds to do the extra computational work. And then it's like, this is not an issue. Like that's just a bush.
Absolutely. And as long as it's trained well, that can provide a lot of value. It's kind of funny because you'll often see people try and use the model to do its own checking.
Which does actually work. It just doesn't work well.
Yeah, exactly. A really good example was a lawyer recently who used ChatGPT to provide citations for his case. Problem: none of the cases he cited were real. He thought about this, so he asked ChatGPT if the cases were real, and ChatGPT said yes, because that's plausible. And so,
but here's how I would solve that problem. I'd say, okay, great. If they're real, double check and cite the cited sources and show me quotes from it or whatever. And it won't be able to do that, not without multiple subsequent hallucinations.
Right. But I have seen it do those sorts of hallucinations. It will literally make up some of the subsequent text.
Yeah. Especially if you're in role play mode, you got to be careful with that one. But I think it is better than people are thinking. It's just not the right way to do it. And I would do a slower. I think we're battling right now with ChatGPT to make it fast, for instance, or Bard, make it fast. Everyone wants this thing to have super fast output.
Needs to be conversational.
Needs to be conversational. But what I need for a penetration testing tool is to be accurate and comprehensive.
Right. And it's neither of those things right
It's
now.
neither of those things because it is optimized for the average, the mean, which is absolutely irrelevant to much of what I care about. I need accuracy, not average.
And I think it's important to note, like, in no way by saying any of these things am I demeaning what it is and what it does.
But we are. We're well, at minimum, we're pointing out
It's not what a lot of people think it is.
Yeah, correct.
But it's an incredibly valuable tool assisting a human being who knows to go and check those sources. And I think you're right. Like, as we get better at wrapping the layers of this tool and using multiple versions of trained databases to sort of watch the watchers and things like that, that at the very minimum, accuracy should increase. Hallucinations should, get some catches.
So with metacognition, okay, I want to be very clear about this because if you use humans, the Copilot method, what ends up happening, if this thing even gets vaguely good, like call it 95% accurate as opposed to what it is now, probably 80% accurate or whatever, the problem is people will get lazy and they'll start just trusting it. And we've seen this come from Google, actually. And so they have a system that was designed to stop negative SEO things or identify negative SEO things, and it never pops because it's very rare.
Right.
But it does happen. And so they stopped looking at it. And so therefore it doesn't do anything anymore. And so what exactly is that tool for? But they feel confident that it doesn't exist anymore, that there is no negative SEO. They're confident, despite the fact that I have tons of people who can tell me right now that it's happened to them. So that's the problem with a Copilot. You have to have a certain amount of it's kind of like you got to train. Right. And you got to train the failure modes. So it should always create a certain amount of bullshit so that, but it should know that it's bullshit. Right. So that the human person goes in and goes, whoa, that's not right. It's like, haha, you were correct. You were paying attention because you should have caught that failure.
It's the Tesla, like, yes, you do have to keep your hands on the wheel check.
Right. Because if you don't, then you're entirely beholden to humans deciding that this thing will do the wrong thing so frequently it isn't worth checking. This happened, the most recent test case of this that's notable was that warship that went down, that got shut down in Ukraine, on the Russian side. And so there's a lot of thinking about how they have tons of instruments. They should have detected this missile inbound, but they had a diagram of what the instrument looks like, that the person who would have seen the missile looks like. And it's green and it's constantly spinning and it's very monotonous looking and it has like a tiny dot that will move across it. And so basically this person has to look at this thing 24 hours a day, and in 99.9999% of the time, or maybe even greater, nothing ever happens on that screen. And so therefore, he just assumes that nothing's ever going to happen on that screen. And that is a terrible assumption because that'll sink your ship. That's the problem with Copilot.
And to be fair, we're seeing that kind of behavior right now with much lower accuracy than we should have on our Copilots. Anyways, we have people using it in spite of its flaws in semi-destructive ways. So there's reason to fear it for sure. I think though that is the other side of it is getting too good one way or another does cause people to walk away from the wheel.
And that's why you have to get people out of it completely.
Yeah.
You can't have them in there at all. If you're going to do that, you have to get rid of them completely. That middle ground where they're staring at a screen 8 hours a day and nothing ever pops up. And then the one time it does, it's always a false positive. So they click through. That
is fair.
That's not a good design.
At the same time, I worry a great deal about the idea of at least with the tech as it exists right now, getting into a position where there's not a human in the loop for an awful lot of the things that people want to.
Yeah. What's your concern there?
So I think because it's accurate frequently enough, and a lot of the tasks that we have to deal with are monotonous. people are attaching it to things that they perhaps shouldn't have. I would be concerned about, say, attaching AI to IoT, or for that matter, giving Clippy the nuclear codes.
I mean, we are really close to doing all that right now.
Mm-hmm.
I mean, maybe not that specific example, but there's already like software that will detect what the conditions in your house are and predictively decide that you need to turn on or off the air conditioning, for instance.
Absolutely. And the hitch to that is that we haven't even really gotten a good handle on securing our IoT very well already.
No.
Because of the way that large language models work, they tend to increase the attack surface significantly. A prompt injection, will almost always result in a lot of content that you would rather, that you don't necessarily intend to be available.
I have done quite a bit of research in prompt injection in particular, and to me, it's actually it's 2 or 3 different problems kind of combined into one problem. First is knowing that you're in an LLM at all.
Mm-hmm.
And so there's ways to do that. You basically, my favorite way is just basically ask it to do something terrible. It's like, I can't do that.
Uh-huh.
I'm an LLM. You're like,
says
no. Which is actually kind of useful. Number 2 is you have to break whatever the current prompt is. And so, and you have to do it as efficiently as possible. So it's sort of like, stop processing, ignore everything I've just said, basically, or whatever, right? And then the third one is actually doing the thing, whatever the thing is. So it's 3 different sub-tasks that need to be accomplished in tandem to make this work, which means that it's probably not, I'm a little hopeful. It's probably not one of those things that we're going to automate super quickly well. However, the pragmatist in me says, yes, but all of the payloads I came up with came from ChatGPT.
Right.
And they all work extremely well. And so if you combine them and you fuzz even just a little bit, you'll unlock what you're after pretty easily, probably within tens, not millions of requests.
It often doesn't take too much work to get, where you're going on those things. And what's funny is that the words you're writing, the tokens you're using are different, but the mindset is very similar to trying to figure out, SQL injection with a prompt.
Very similar.
It's very much, escape what's in there.
Find out that you're having the problem in the first place.
Yep.
Escape and then do your payload.
Do your payload, and that payload can be very exploratory. I personally expect us to see a nasty rash of people using LLMs in multi-tenant applications that don't realize that if you can prompt inject from any one, it'll give you whatever it knows. I think we're seeing an awful lot of cases where it's being set up without that sort of knowledge segregation.
You bring up a good point. There's also the fourth, which is making it semantically correct, which is possibly like ignore everything after this line or whatever,
Yeah.
So are you actually seeing this in real apps currently today where apps are actually vulnerable to prompt injection?
So in a sense, no. We've done a little bit of LLM testing. The thing that actually concerns me, and I was reflecting on this just yesterday evening, is that for all that we're seeing LLMs being rolled into applications aggressively and widespread, we're not really seeing as many of those come in for testing quite yet. So my personal hypothesis is that
it's coming.
Yeah, exactly. I think an awful lot of people are running these in, pushing them to production, and then just assuming that this will all get caught in their next test. Never mind the fact that, honestly, if you're rolling in an LLM, a threat model is probably the first thing you ought to be doing, well before it ever hits the production stage.
Yes.
But we still haven't seen widespread threat modeling being executed as much as it should be.
Yeah, I think my advice I give to some of the marketer friends who are actually building apps exactly like you're talking about, and they're just rolling it straight to production. There's no testing whatsoever. I mean, feature testing, product testing, but no security testing. Not even necessarily QA testing, just like, let's get it out. This is cool. You know what I mean? I'm just telling them, look, if this is something you pre-computed offline, like if you're like creating a landing page or whatever, you're good to go. You're fine. Assuming it came from you. It didn't come from your logs. It came from you.
Right.
If you're taking user input and throwing that into an LLM and then taking that output, even if you're doing what you think is sanitization on the way out or whatever, you are very imperiled, and you should be very concerned.
Realistically, anyone who's doing work with LLMs right now needs to be paying a lot of attention to security. OWASP just released an LLM top 10 not terribly long ago. A member of my team was actually involved with that.
Oh yeah, I don't think I've seen that.
It's pretty good, and as effectively, if you're familiar with the top 10, it's going to look very familiar. In many ways, LLMs are an extension on or an increased attack surface on what is otherwise a standard application security problem. It's got a few extras on it. It's got prompt injection as opposed to regular injection. Things like over-reliance and model theft are called out explicitly. But by and large...
What about like overfitting and that kind of stuff, or like bad training data?
Yeah, so they do talk a little bit about poisoned training data in particular. And that's something that I think a lot of people really just aren't considering nearly enough anyways. The neatest ideas people have for these sorts of like models, for ML in general and generative AI in general, often involve like retraining and expanding and continuing to change the model in response to the environment. But that introduces an attack vector that has been around well before LLMs were widespread.
Interesting. Yeah, I need to check that out. I don't think I've seen that.
And
obviously super familiar with OWASP, but not that particular project.
It's hot off the presses. Also of note is that I think on October 30th, so very recently, the Whitehouse did an AI-focused executive order.
Yeah, so that one I have read. It was like 26 pages or something. It was pretty comprehensive. Sorry. There's two different things. Right. So that I've read both of them. So there's another group within the DoD who's also produced something. That was what I was just thinking. But yes, I have read that one as well. That strikes me as not really understanding the problem.
Yeah.
I was really disappointed. In fact, I was been to the White House and I told them don't do that, and they did not take my advice. And oh my God, they're gonna cause all kinds of problems by neutering the systems and making it hard to deploy. And
yeah, there was it's funny because I'm sure there's value in getting everyone to think seriously about it and raising it as a topic. At the same time, it kind of waffled between unactionability and overfitting.
Overreach. Yeah. It's like, why do you care about this? I think the number one thing for me is censorship. This isn't just a la liberté, I don't know. It's not like me just like wanting to see whatever I want to see, which I also do, especially in my line of work. I need to know everything, not just, cherry pick, the most thing that makes me feel good or whatever. I need to see it as it is. It's actually one of the reasons, by the way, speaking of like burp, since we mentioned it earlier, one of the reasons I always like that is because it didn't modify anything. It's exactly as it came across, and it didn't try to make it look pretty. It just told me exactly, byte for byte, exactly what was going on.
Unless you edit it.
Unless you edit it, right? Which is perfect, and that's what I want to do is I want to edit it. But LLMs, like ChatGPT, for instance, is so censored. It's so designed to be the gutless medium. It's not willing to be provocative at all in either direction.
Conversations with it tend to be fairly empty fairly quickly.
Well, it's not just that. It's not like I'm going to get emotional enjoyment out of the conversation anyway, because I know I'm talking to a robot. But what I will get is utility. And if it's breaking its utility, that is a massive problem for me, because then I just can't use it at all. I end up having to go build my own thing. And then what's the point of having this software? So I think that's... rumor has it that Musk is building his Grok or whatever, that will be the based AI that will have zero controls or whatever, which basically the White House basically said, no, you can't do that.
Right.
Which I don't know how they're going to make that one work.
Yeah, there are going to be a lot of questions, I think, in terms of like whom that would apply to, what the circumstances are. In some sense, I think the LLM genie is out of the bottle.
Totally. 100%.
I absolutely think it's great for people to be thinking about this, but there will be some realities that will be either like physically or politically, impossible to achieve in terms of controlling it. So instead, we're going to have to find ways of living in the world that it's building.
Yes, absolutely. I just worry that the next generation is going to start speaking like an LLM. I mean, I've already started doing it.
Lots of bullet points.
Not that. But there's certain things that it just doesn't do well with. For instance, let's say we're talking about a complicated scenario. I'll use they as opposed to the person's name in normal speaking. I'll be like, oh, we have some people over, Joe and Sue and whatever. They did blah, blah, blah. It will confuse what I mean by they sometimes, where humans wouldn't.
Right.
So I end up being overly verbose and explaining what I mean is Bob and Sue specifically were there at this specific place. And by this place, I don't mean this place in which we are currently at. I mean in this place in which I am talking about, which is the house. I end up using way too many tokens because if you don't, it gets confused. And kind of rightfully so. I wasn't very specific. That's my fault, I guess. But when you're talking about social issues or whatever, and it won't even give the other side on some issue, period, because for whatever reason that's outside the mean of its algorithm, that is a problem because then you don't even get conflicting science.
And there are a lot of potential angles on that discussion, whether it be like, is the data that's being used to feed that, biased to begin with? Is the model trained such that it's only going to respond one direction or another? Or is it simply responding arbitrarily or specifically to circumstances?
It's kind of all of those problems.
Right. Like frequently with these sorts of pieces, because it's somewhat limited in how long it can respond, you'll see cases where it'll just pick a side and respond because that is a natural conversation. It certainly doesn't have any particular intent attached to it, and may not even be a question of training data. Might just be a question of brevity, and then deciding to go one way or another at the flip of a coin.
Right. That's terrifying because if it chooses token length over truth, that is a big problem.
Well, again, it doesn't choose truth at all. It chooses plausibility.
Yeah, but I mean, if it knows that this is a better answer, but it's too many tokens,
right? Oh yeah,
it will still fit the worst answer.
It responds to the best of its ability,
right.
And I do think some of these things will, if not go away, at least be mitigated as we approach scale in some fashion. More tokens, more better. But I think these problems are going to be around for a long time, and I think our needs will grow to match our token availability as well. So I think these are the kinds of discussions that will have to be had and architected around.
So let's talk about blue teaming. So we talked a lot about how to do bad things. Let's talk more about how the average person is going to use an LLM to protect their company. What are some of your more favorite use cases for that?
So I think you referenced some of the best ones. To some degree, a lot of these sorts of things can be used to automate away very tedious tasking. This can include, adding co-pilots to make our software dev better or cleaner, especially if they're security trained, so that they'll catch some of the mistakes we're making before we make them. It can be used for things like monitoring, or even a triage support.
Yeah, let's dig into that one. So how would a company use that today? Like what would they do?
So if you were setting up something that was going to try and do that, then you could try and take a look at a history of trained content related to your triage, especially in very large organizations that have been doing this a while. They've got plenty of their own. And I guarantee that some of your favorite SAST providers are rolling in some AI support, as we speak, maybe tested, maybe not. But a lot of times, going through and finding all these false positives, marking the likely impact of each one of these vulnerabilities is a very manual process, but it's built on reading code and understanding the context of that code. It would be lovely to have some support that'll at least give you some hints about where to look, and some broad guesses as to what you're looking at while you're doing it, even from a co-pilot standpoint. Later on, when you start getting into some of these monitoring pieces or triage pieces, the inverse becomes more possible as your accuracy goes up. You can say, hey, this looks particularly bad. Let's get a human in there to go look at this individual thing, and then get to the rest when you get to it.
So. I think one of my I think favorite things to think about in terms of blue team would be reducing dwell time. So I think AI could help a lot with this.
In general, like anomaly detection has been a challenging problem for a long time.
This is back to this person looking at the scope problem.
Mhm.
Like, frankly, we've given them that scope. We're like, here's this thing just giving you false alarms constantly, and it's very boring to look at. Even the pew-pew maps are just terrible, and you're just like, what am I doing here?
Yeah, these intrusions were in the log. Why weren't you reading that log?
Yeah.
All
Are you kidding me? All
75 gigabytes of it.
There's millions of hits hitting the website today. You want me to look? You want me to find that one in the haystack? Like, there's not going to happen. And by the way, we're getting attacked all the time. So why would I notice one extra attack? It's like, there's tons and tons of attacks coming in. Yes, you want me to give you a log of all the horrible things that people try to do today? Because I mean, you put a computer online. I forget what it is, but it's something like 15 seconds or something before something malicious will try to hit it on average. That's
I mean, it's
what are you gonna do? Like you just created that terrible dial thing all over again. So
and realistically speaking, when an attacker does succeed, one of the things that they try and do is obfuscate that fairly quickly. So unless you happen to be looking at the right time, you're going to be struggling to tell
the
what
right
happened
log
at the right log.
Yeah.
So building these sorts of and there have been attempts to do this that don't require LLMs. Obviously, like various forms of intrusion detection have looked for these sorts of anomalies to varying degrees of success. I think there's a lot to be said for the fact that as we train this up, we can catch a wider spectrum of things and refer them to humans before it gets into the desperate and damaged stage without the human necessarily going cross-eyed reading a ton of logs.
Yeah, this actually to me seems like very promising work because it can take a lot of logs that are well formatted from their perspective but maybe they're in a weird time zone. Or maybe I have a log, this one's an Apache log, this one's an IAST log, and they don't quite match, you know what I mean? Like they're close, but they're not the same. Or this is like an SNMP thing, or this is like this, some bind log or whatever, some weird stuff. And it's like, look, here's everything that happened at this time. It's just but I don't figure it out.
Right.
And it could create a pretty good and fairly, I would say, comprehensive way to read all of that stuff and think is, I'm using that word, I'm putting a lot of effort into making that word work, but you get my drift. Yeah. It can process all of that information, and then you give it some context. You're like, okay, well, if like this is how these things are related, and these things have access to one another, and this has the critical thing on it, and blah, 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 and you give it some knowledge. And then that's more than any analyst is going to do on any given log.
And I mean, right now, one of the most rock solid cases we have for these LLMs, one of the things that it does best is summarize content. It's a clear use case, it's an understandable use case, and it does a pretty good job of it. This is just specializing in something that we already know works fairly well.
And then the part that I like about it is that you can run it millions of times a day. So I no longer have to have a human being who just gets bored. I mean, frankly, they're expensive too. This is a very expensive task. But imagine a managed security service provider, MSSP, who all they do all day long is ingest all these logs and process it on behalf of their customers. So they've inherited all the costs of the LLM processing and data ingestion and all that stuff. And all they hand is back is actionable data back to their NOC or whatever.
Go do the thing.
Go do this very specific thing. You have a compromise on this box. I think you could dramatically reduce dwell time. And I think what we're seeing now, and obviously this can and probably will change, but it takes sometimes months before the bad guys do anything once they're on those boxes. It's not like they're that day going in and extracting all the data and getting out. It's the opposite of what everyone thinks. Like, how fast can you get in this box? Like, I don't need to. Yeah. I don't need to be fast because you're not going to notice me anyway. I'll sit there for 6 months, just siphoning off information, learning more about you.
And most of these are even getting in there as parts of like automated processes. Many of these hacks are done as in sweeping ways to lots of companies at once, and then you get in and you just see what you have. Every network is different once you're inside, so might as well find out what you've got.
Okay, so we talked a little bit about SAST, but I think that's where a lot of people are hanging their hat for LLMs.
Yeah.
What do you think? What do you think about that? Is that going to work? Do you think that will be, because that one seems tricky to me, because there's a lot of logic stuff going on. There's a lot of knowledge, a lot of complexity. Half of what we talked about with mobile, for instance, is setup. And it's just brutal. I mean, it's tough. Scoping is hard. And I just don't think LLM, despite the fact that I hear a lot of people talking about, I don't think that's a great use case for LLMs, just because of all the tear down and scoping. And
it has its ups and downs. The first thing that's worth talking about with that is obviously, and this is true of all of the security pieces. Honestly, it's true of LLMs in general, is that we do have to be concerned about what we're putting into these LLMs and the provenance of our LLMs. We have to make sure, that we have permission to use this data in this way, and that it's not going to be saved in places we don't want it to be saved, et cetera, et cetera, et cetera. So
wait, you're actually figuring out what the provenance is? How?
Well, that's the problem. Yes.
Okay.
Exactly.
All right, okay. I was gonna say.
So there are roadblocks to using it, like in our field, just to get started. That said, I do actually feel like those hurdles aside, SAST has some options, mostly because I've been really disappointed in the current state of SAST.
Why is that?
In a lot of cases with clients that we go to, we can go in and say, hey, do you have SAST? You should probably stand up some SAST. We have cases where people will have stood it up, and they didn't know how to use it. They did a poor job of dealing with it. They struggle with false positives. They struggle with triage. They struggle with actionability. That false positives is a big one. It comes up nearly every time anybody talks about it. They're like, well, we just had too many false positives. It wasn't worth their time. And so they're missing out on extremely valuable intelligence about their system, because actionalizing the work is a bridge too far in many cases. What's nice about LLMs is that either in concert with the existing pieces or of their own accord, they're doing fairly well, even relative to the tools we have out there. That's neat. It's still going to have false positives. The reason I'm kind of optimistic is that it feels like, especially for some of these folks, these companies that specialize in this, they have access to so much data that they can customize their models, to fairly extreme degrees to try to turn this into something a little bit more fixed and firm. Is it easy? No. But this falls into another case of like, none of the SaaS tools out there are, finding everything 100% of the time or 100% correct, in my experience. So I think there's a lot of room for improvement in the field that this might drive.
Back in the old days, we did some preliminary assessments of SAST versus DAST at Whitehouse, and including competitors, not just us. And the overlap on the vulnerabilities they found was like sub 1%.
Yeah.
That's just terrible. And all of the DAST ones we knew were real exploits.
Right, by definition.
Right. Oof. All right. So the other thing I was thinking is there might be an option to use an LLM to define better uses of better frameworks. So right now you're using whatever you're using, is let's say some ancient something or whatever. And it's like, well, you're using this thing. It's not necessarily vulnerable, but it is very antiquated and funky and end of life a long time ago, et cetera, et cetera, et cetera. Or maybe it's like, this has a bad trend line. There's a lot of vulnerabilities in this particular, attackers really like this thing, for instance. Consider using some other framework, or we know this other framework can solve this problem better, cheaper, faster, more secure. You should probably consider this other thing. Have you thought about that at all?
So in a lot of ways, once again, noting the hurdles to using an LLM, I am optimistic about their ability to support operationalizing reporting. So take the contents of a pen test, an assessment, and sort of more rapidly turn around a lot of those sorts of recommendations, clean up your text, and provide like a more direct looks at these. And to your specific point, like supply side concerns, those are notoriously difficult to just follow and track. So,
yeah, but I mean, there's databases for it, so it's not. This isn't like outside the realm of possibility.
No, and there's plenty of data to feed into those pieces or into these sorts of models, and creating more useful content around those vulnerabilities has a lot of potential to make that more useful. It's fairly common right now to provide warnings about supply side concerns, and just have them written off as false positives. In fact, like many people are running sort of SCA tools and do absolutely nothing with the tools that they're running. So
right.
So honestly, if LLM even helps to turn some of that into usable data, then we'll be seeing a measurable increase in value off the bat.
So I think there might also be a use case here. It just occurred to me, something like SBOM plus SAST, and AI is kind of in the middle saying, okay, well, yes, this is vulnerable, but it doesn't run in memory, so don't bother reporting on it, or you dramatically reduce it so it's informational only or whatever.
I think anything that results in sort of crossing of more sources of data to produce that action plan is going to provide a lot of benefit.
This is where I think IAST was supposed. The promise of IAST, but not what Gartner said it was, but the real promise of IAST, the marriage of DAST and SAST, was going to be, or dynamic anything and SAST, was going to be truly amazing. But then they wanted to make it like super duper narrow. And I'm like, yeah, but you're missing so much interesting stuff. Like we can build these other components much easier than saying this DAST vulnerability is this line of code in SAST. Like, yes, that's kind of nice. Sure. Yeah. I mean, maybe even very helpful when I'm trying to fix it. But people are going to find the line of code. Like that's, of all the problems, I'd say that's fairly low on my, where I'd rate things. But what they aren't necessarily going to find is that they're not testing everything in DAST. Like there's this whole other chunk of the app. Like that's enormously useful. You know what I mean? Like you find all kinds of stuff you weren't expecting to find, or, it's like, oh, actually there's all these API calls that you're not hitting that you don't even know are in scope that are behind the scenes. Like you should go check these out.
And tangentially related, like this leans into why I'm such a big fan of threat modeling as an activity that people should be performing, is like the interconnectivity of different subsystems is really where a lot of the nasty stuff is found. So in isolation, we test an awful lot of these pieces, and we never successfully, we never really get to see, how deep the rabbit hole goes.
I think that's got to be one of my biggest pet peeves, is not properly scoping things, because that's where all the that's the bad stuff. I mean, Equifax, Target, Sands Casino. I mean, these are not trivial compromises, all related to just scope is not in scope.
Yep. It's when we go and do these sorts of threat models at Coalfire, we're often looking at like not just the system that we're asked to do, but its place in a system of systems. And
so do you actually do threat modeling for them?
Absolutely.
Oh, that's cool.
So we do a few different things. One being doing threat models for them. We have our sort of own format that we've developed for that. If you go back far enough, it's built off of the Microsoft one, but in a lot of ways, threat models, as they're done sort of industry-wide, are often like love letters from one attacker to another. So we've tried to adjust it to be a little bit more defensively focused. So we'll absolutely do threat models for them. We'll interview their team, their leads, their SMEs, build out data flow diagrams, go the whole 9 yards.
I think this is actually this is really important, because I've only done it a handful of times back when I was a pen tester, but occasionally I would be asked to go in and like actually interview their people to make sure they're doing what they say they do. Just basically policy enforcement. And I remember this one where I went in and this guy just would not talk to me at first. Like, you're just some consultant. You're just blah, blah, one of those, you don't know what you're talking about. And I'm like, okay, let me tell you everything that I do know. And I walked him through everything. He's like, wait, what? Like, that's not true. I'm like, well, this is what your policy says. And I saw this guy over here and he said the blah, blah. I was like, okay. So now I'm no longer the jerk. That guy's the jerk, and that policy is stupid. And now he's willing to talk to me. And one of the policies was there is nobody in the company who has access to root. No one has access to root. It's in the policy. And he's like, We have 400 people who have access to root.
Absolutely.
Like, that is a substantial difference.
Every time I did a threat model, one of the most entertaining things about going and doing those interviews is the fact that you will get wildly different answers to very, very important questions just by going one office over and asking the same question to a different guy.
Yeah. That's really scary. The policies, I did some policy assessment for another very, very large company, different company. And they were pulling in a policy from a guy. This policy was written back when I was working at a company that is now long been migrated and defunct and whatever. It's called Digital Island back then time. But John Stewart, who eventually became the CISO of Cisco, actually, he worked one office over for me, and he wrote this policy document, and it was referencing his work back then. This is before really web application security even had the name. It was still CGI security back then. And it was referencing documents on the internet that these websites don't exist at all. And I'm like, this is like an enormously, very, very important company. Like, you use them all the time. Chris uses them. I use them. They're very, very, very important company. And I'm looking at this policy document. I'm like, no one's looked at this thing. You couldn't have, because if you clicked any of the links, they're all broken. Like, oof.
We absolutely, so in addition to doing threat modeling for people, we'll go in and build threat modeling policies and procedures for people, application security programs for people, write a lot of those policy documents. And we see the same sort of thing. Most companies that we go in to help have some sort of policies on the books. No one's read them. No one's used them.
Yeah, no one's read them. That's the important part. So this is back to the screen. Like, so we have the policies. They're working in 99.9999% of the time. There's no problem with our policies. But no one's looking at them also, which is why you don't have any problems with them. So this is another place where I think LLMs plus a little bit of API magic could be amazing to help GRC. So like, you take in your threat model. This is what you're supposed to be, this is what you want to know from the data. You feed in the policy document and you say, all right, APIs, go off and connect to the firewalls and see if the ACLs are actually blocking this port that we say we're blocking. No, they're not. Great. Okay. Failure, and so you can just quickly go through and find all this garbage in their environment without having to interview people specifically. There's obviously going to be situations like where do you store your backups? You're not going to get that through an API,
Yeah.
But the vast majority of that stuff could be totally automated.
And once again, we're talking about the kinds of problems where any benefit is strictly benefit.
Archer's never going to do this, by the way. I mean, it's just never going to do it. It's going to have to be a net new vendor, somebody who's fresh off the boat, who sees more holistically. This is, by the way, one of the very first and probably very best use cases for blockchain. Because what I really want to know is forensically secured. I want to know that my environment looked like this at this time.
Attribution, provenance.
Right.
Those are really the things that blockchain excels at.
Incredibly useful. So if I know this firewall changed at this time, and so the attacker could not physically have gone through before that, but they definitely could have gone through after that, then I've narrowed down my window. Or if I know that the firewall's configured like this, consultant came on site, firewall's now configured like this, it's a pretty good idea who did it. You know what I mean? Even if I don't know the raw logs, I can still tell, the configurations or whatever.
You have a window at least.
And then you tie that into a GRC and then throw an LLM on top of it, and you can tell exactly what your environment looks like, what you should fix in what order. I mean, this is...
And once again, like, there's still an accuracy problem. There's still a completeness problem. You don't have to be completely accurate to see benefit.
But consultants are going to be way worse than that. Way worse than that.
Can be.
Way worse. Because they're not going on to every single firewall, dumping every single config every single day at all times. You know what I mean?
Absolutely. So I think in we have a lot of great use cases right now where perfection is not the goal. Improvement is the goal.
Yeah, sure.
And I think just as a society, the more we lean into those use cases, the more value we're going to get from this technology that emerges.
Yeah, I'd say the biggest problem we're going to have, and this is going to be a Herculean upgrade, is getting APIs from all of those different vendors, including your IoT devices you're talking about, including all these third-party vendors who are doing, whatever they're doing. Maybe it's source code analysis, maybe it's analyzing logs or whatever. All of them need to be able to speak LLM now. All of them.
Mm-hmm.
They need to be able to give me information in a way that I can process and turn into an LLM. I think that's going to be the next 5 years. I think everyone's going to be focused on that.
And the security consulting industry will benefit.
All right. So how is Coalfire using AI today? What are you guys doing?
So right now it's fairly limited. We've pulled in
other than breaking it.
Right. So I think we have an internal instance for limited use cases, but much like everybody, I think we're growing our use or still exploring its potential. Given our industry, we're having to take that slowly and carefully and think it out before we execute.
What instance are you using internally? Can you talk about it?
I think I best not.
Okay. Fair enough. I've looked at a lot of different models, and I have not found one that I think is there.
Yeah.
So I could tell why that wouldn't be a slam dunk if you're using any of the ones that I've looked at.
Right.
But it's getting there. It'll be a year, and then you'll have it.
And realistically speaking, that's going to be everyone's answer right now is that it's exploratory. I think the value in the tech is there. I think we're going to be seeing it, and we're all going to be using it in a variety of ways. I think the best thing we can do is do so in a thoughtful way.
Mm-hmm. Have you explored using Azure and pushing all your data into an Azure instance and using ChatGPT through that? Because that is a path.
Yeah. So I think in a lot of so all your data is always a scary phrase.
Yeah.
So I think we're I at least would advocate us taking a much more limited approach to those sorts of things.
Mm-hmm. But have you explored it? Have you tried it at all?
I have not.
Me neither. I've kind of been curious to do it, and apparently they have kind of more bespoke controls built into Azure. So maybe I'll take that as a homework assignment and go try it out at some point.
Seems worth trying.
Yeah, well, I like it because you do have some level of data sovereignty, some, not a ton, right? You still are within a cloud environment.
Right.
But you're so close to ChatGPT, you don't have a lot of latency issues, so I don't have to push massive amounts of data for every query. It's right there, which is nice. I mean, you still have to push it up once, but you don't have to push it on every request, which that's never going to work. So there's a lot to love about it, minus the privacy and safety and all that other stuff, which I'm still a little wary of. But it's not like we've ever had any cloud issues. Come on, what are you talking about? All right. Well, so any advice to companies about greenfield applications, since we talked about that a little bit? I mean, if you were starting a brand new, let's say, web app with a iPhone, let's say companion app kind of thing to it. Any advice you give companies these days?
I think first and foremost is the obvious one, and that's that an application that uses an LLM is still an application and needs to be treated as such. This is not a small feature add, no matter how easy it was to add. So, begin by doing your due diligence. Use it with care. Manage your input, manage your output. Know where your data, know your data provenance. And
but there's no way to do that with ChatGPT.
Right. So phrased another way, know the risk from not knowing your data provenance.
Sure.
Do your tests, do your pen tests. Don't trust that this will be safe going out there. It may have unintended consequences. It's fairly non-deterministic, meaning your typical out of the box tests may not cover nearly as much as you hope they do. In terms of
is there anything that's like this? I mean, that's a very important point. The non-deterministic aspect of it. I'm trying to think, is there anything that's really like that? The only thing I can think of is something that might be user related, like the user might be logged off and therefore X, or the user might have clicked this button and therefore X.
Yeah, you see behaviors a little bit like this in things that use live data and are constantly rolling. Because the current state of the system may change at any given moment. Kind of think race condition in a sense.
Yeah.
Only on a much grander scale and with much worse consequences in many cases.
Yeah, I guess I've run into similar situations when trying to do brute force attacks, specifically with credentials. You think it's going to work, and it doesn't. and you're like, oh, well, maybe I got this wrong. And then you try it again, and then it does work. You're like, whoa, and then it worked. And it's like, oh, no, what's really happening is a person's on the box doing something.
Yeah. It feels like the definition of insanity, like trying the same thing twice and getting a different result.
It's like, wait, why is it not working now?
Right. But I think we're seeing a lot of cases too. And this leads into my second big recommendation for people that are considering using LLMs at all, which is know whether your use case even needs an LLM. Realistically speaking, adding one is going to increase the attack surface. So understanding, understanding.
You mean a live one, though?
Right.
Yeah, I think that's important because a lot of people can use it in their home or whatever and dump out some text that they put on a website.
Sure. But like incorporating an LLM into your system, into your application, is increasing the attack surface on said application. So understand, like, could this have been done with a switch statement? I think we're seeing a lot of cases, just in the wild, of people using LLMs because it's new and cool, or because it's really easy. It's like, I can just ask this thing for an answer and it'll give me an answer.
I would love to see the very first day that somebody says, you shouldn't use an LLM in this application. Just use an if statement.
Right. Exactly. Because
that will happen.
Could this be solved with a database?
Because the answer is probably very often yes.
Yeah.
But also maybe not. I think people are getting more and more creative about this thing.
As people get a hold of the tech, I think a lot of the things that are really simple are falling by the wayside, and we're getting into sort of the meat and potatoes of where we'll see value on this. But for greenfield applications, start by asking yourself, like, could I solve this with a switch statement? And then move on from there. Because if the answer is no, you might have a really cool solution, but you also now have to think about a lot of additional security concerns that maybe you wouldn't have had to.
Yeah, I was looking at an app that I think was released a couple days ago, maybe. It was basically, just it takes a photo of you and uploads it to ChatGPT and says what's in here. And it's like, oh, there's a person or a person holding sunglasses or whatever. I'm like, there's a lot more going on there than just a person, right? Mm-hmm. And so if that's your level of granularity and specificity, your app had better been person or not person app.
Right, exactly.
Because there's a lot more happening there.
And depending on how the model you're using is being trained and the source of the data that's coming in, you can't necessarily get, if you're thinking it's a person or not person app, it's going to be really awkward when it tells you it's sunglasses, like, 5 years later.
Right.
Or like not a goat or something.
It's a goat. It's definitely a goat.
Hot dog, not hot dog. I mean, really, that's a bit of a scary thing because, as you said, it's non-deterministic. I can't even tell what it might put out. Mm-hmm. I can't even tell what the use cases are. I can't even tell what format it's going to come out. Like, I've done a lot of struggle busing to try to get it to output like JSON LD or something. And it'll do it, but then it'll put like here's your JSON LD at the top that's not in JSON LD.
and in many cases, you're beholden to the owner and the creator of these models and tools. If ChatGPT decides it will or won't do something tomorrow, you don't have any control over whether or not it'll continue to return these things. So if you have built your application hinging on it responding in a certain way or responding at all, then you may find your application is a bit of a paperweight.
That is precisely why I have not created any apps tying into ChatGPT and the API. Mm-hmm. Zero. The other version of that problem is their algorithm changes pretty regularly. So even if you could turn down the randomness of any individual query, the underlying data might change. Mm-hmm. And so, it's working great. And all of a sudden it's doing something really weird.
And to go a little bit future problem, as if we don't have enough problems today, the ChatGPT up until this point was trained on a corpus of knowledge that was not aware of it up until very recently.
And now it is.
Now the internet knows about it. And there's going to be someone who's trying to figure out if they can affect the output in the future.
Yes, I think there's a lot of people thinking about that. One of the scariest was, I think there was like 20 or so different websites that it was using that don't exist anymore. Mm-hmm. And so someone can just re-register them. And so
become the answer.
Yes. So I think that problem has been solved, which is why I feel comfortable talking about it. But there's a lot of web apps, and I know a thing or two about web apps, and they are not particularly secure.
and so like some of this is kind of playing the long game, but we have people, including state actors, who are very willing to play the long game.
Yeah. And so back to your, now the internet knows about it. it's also going to become more and more incestuous.
Mm-hmm.
It's going to be feeding on its own data that's been outputted that people have uploaded to websites.
And this is a bit of a problem that comes up in particular with AI art. Much of the AI art that is out there, all of it in a sense, only exists because there is a large body of, created art to feed those models. But there's a lot of controversy in the artists community about like the value of the work that they're doing and how comfortable they are continuing to do it when they are being used to train models without consent. Meanwhile, there's a big old pile of AI art just filling up deviant art, that may yet become the next training data for the next version of the model.
Almost certainly will. Well, this is terrifying and interesting. So where can people find you or find Coalfire? Where do they get in touch with you?
Coalfire.com.
Okay.
Do
you have any social you want to throw out there as well?
I'm on Facebook. I'm on Twitter as Altitude Matters. I'm on SoundCloud as Altitude Matters if you want to hear some jazz.
Cool. Smooth jazz. Love it. All right. Well, Kyle, this has been amazing. Thank you so much for flying all the way down. Really appreciate it.
Yeah, thank you.
Yeah.
Thanks for having me.
Thank you.